and today I'll discuss about the recursion. Before going to learn the recursion, I would like to discuss few things related to the function. Since we are learning the function from the previous few sessions, so I would like to discuss few more things related to the function calling and the execution process. Then we will learn the recursion. To understand the recursion in a very well manner, that how the recursion gets called and how your application gets executed. So first of all, understand this point that I'm going to discuss here. If you define any function, for example, fun1 in your application, and if you write some statement in your function, so for example, if I write only this is function uh, function1, okay. And we know that in a Python script, we can create any number of the function. So it doesn't matter that how many functions you have in your uh, script file. So let me create one more function, that is function2 here. And in this, I will write here that is the function2. And one more function I'll create here. Let me copy and paste. And here I will paste it. So as you can see, I have created three functions in my script. So in which order your function will get executed? First of all, understand this one. So in Python script, in which order, in the order in which you call the function, then that function will execute in that order. So for example, if I write function1 here, and after that I call function2 here, okay, that is called function2, and here is function3. Okay, so first of all, your function1 will call, then after finishing of this function, then function2 will call, and after finishing of function3, function2, then function3 will be execute. This is the process of the execution. How your function gets finished means stop the execution of its body. So there are two situations. Okay, one is called when all your statements gets executed, whatever you have written in your function, and if you have a return statement, so your function will finish the execution. What is mean by this? For example, if you write here that is if certain condition, suppose there is a number that is equal to 10, and after that you write here that is return. So after this statement, let me do this. After if this condition gets true, then it will return. So after this return statement, your this statement will not execute. I hope this line is clear to all of you. So the function will finish in two situations. One, when the return statement occurs, and second one is when all the statement that you have mentioned in your function gets executed, then your function will gets finished. So how your function gets executed and how your application maintain these functions calling. So actually, the function when your function start the execution. So since you can see here that here the function1 is calling first. Okay, so this function will call first, and it will go into a memory area that is called the stack memory area. Okay, so let me draw that stack memory area here. So this is, for example, this is a stack memory area, and here I will write that is a stack. So this is your stack memory area, and this function1 is gets called. So in this stack, your function1 will be placed first one. So this is your fun1. Okay, and it will start the execution. This is a stack, and a stack means the function which will come first will be execute last. Means that is other thing I will discuss later on this topic. So function1 is here, and when this function will start the execution, your control will move from here to the function one, and it will start the execution. So it will see that the print statement is here, so it will print function 1, and after that it sees that there is no other statement, so it will stop the execution, and after that your control will be back to this function 1. Okay, and after this whole statement's execution, this function that you have written inside, means that function that is inside a stack will be come out from the stack. Okay, so when this function will be finished, then your stack will be empty. After that it will come and execute the next function, that is your function 2. This function will be finished. Okay, so now this function has been finished and function 2 is called. So now the function 2 will be placed into the stack. This is 1 2, and after that it will go to this point, the function that you have written, and here it will come and it will start the execution of the function, and it will execute the statement that you have written into the function 2. So as you can see that there is only one statement, so it will print function 2, and all the statement has been finished, so it will come back to the location where you have called this. So this will be at this location, and after that your function 2 will come out from the stack, and it will finish the execution. After that you call the function 3, so it will call. Similarly, this process will be continue until your all functions has not been completed, and your script will execute till then. And after execution of all the function, and when your stack gets free, then your application will stop. So here if I run this one, then you can see that here the output is in the same order, as you can see here: function 1, then function 2, then function 3. This is the way that the function gets executed. But there is a twist in this whole scenario. For example, as we know that a function can call the other function. So for example, if fun1, okay, is now called by function 2, yes, we can call this. This is the very simple thing, that a function 2 can call another function, either that is built in or your user defined function, it doesn't matter. So it is calling the function 2, and now function 3 is calling function 2. Yes, it is also a very fine statement that we can write in our application. So this function 2, and now I'm calling the function 3. So what will be the stack format of this? Why I'm discussing about it? Because when you will use the recursion, it works on the stack format. So if you understand how the stack will execute, then you will get actual formation of the recursion, and you will get understand that how to use the recursive function in the application. So when I will call the function 3, so first of all it has been called, so it will be placed into stack. So it will go and it will be in function 3. Now this function is placed into stack. So it will go at the location of function 3. So it will go and reach here. Okay. And as it will enter to execute the function, it finds, okay, I need to call the function 2. So it will pass the execution from this location to the function 2. Means your control will be passed from function 2, when this location 2 means to this location. So it means now you have called the function 2, so it will placed into the stack. Now one more block will be available, and here your next function will be available, that is function 2. Okay, and as the function 2 will start the execution, it finds that I have one more function to call, that is function 1. Okay, so it will call the function 1, and your control from here to reach at this location. Okay, so it means function 1 will be placed into your stack. Okay, so now one more will be available here, and it will contain the function 1. Okay, now as you can see, the stack, at the top of the stack, function 1 is here. So until the function 1 is not finished, your function 2 cannot be continued. Okay, and until your function 2 is not completed, then function 3 will not complete. So now this function will start the execution, and it will print function 1. Okay, it will print function1. And after this function will call here, and when this function has been finished, so it will be out from the stack. So now your stack will be uh, your output will be function1, and from the stack function1 will be removed, and after that it will reach at function2. Why? Because the function1 is calling from the function2, so it will reach at function this, and after this it will print the function2, and after finishing of this function2 it will reach at function3. Why? Because the function2 is called by function3, and now function3 will continue and print the function3. So your output will be function1, function2, function3 in this order. And you will see that we are calling the function3, so we are not getting only the answer of function3, we are getting the order of this, because this is the order which is maintained by your program, your environment to execute the functions. So let's see what will be the output of this code. So here you can see that function1, function2, function3. So this is the process of the execution of the stack. So I hope this one is clear. So now, as we can see here that a function can call another function, and we can maintain the stack, and this is the order in which your function gets executed. Now come to the recursion. So what is a recursion? Let me clear all the drawings first. So what is called recursion? Recursion means defining something in terms of itself. This is the literal meaning. But in terms of the programming, if we talk about the recursive function, so it means that when a function call itself means a function hand over something to produce the output to itself in the next call. So it is called recursive function. So this is called the recursive function. So what is mean by this? For example, if I have a function that is my fun here, and this function printing something, for example, it prints Python. Okay, and after printing, it call itself. So what is mean by this? When this statement will finish, then it will call this statement. So this will be placed into stack, and this control will be reached at this location, and it will start the execution of printing again, and again it will execute this one. So this is your recursive function. Okay, means a function is calling itself. So let's execute this one. So here is my function, that is my fun. So if I call this and execute this, then you will see here that we are getting error. Yes, we will get error, but look at here that we are getting the output so many times. Okay. So if you are coming from any other background, for example, C and C++ and Java, then you will find that if you write this kind of the code, then you will be enter into the infinite time execution of the function, or we can say that until your stack gets full. Okay, the right statement is. So here is the limitation for the recursive function execution, the default limitation. The default limitation of the recursive function call is 1,000 times. Okay, because when we write a recursive function, so we try to achieve some functionality in some recursion, some time of the calling of the same function. So Python does a very smartly thing that it has fixed that how many times a recursive function can be called. So it has been fixed as 1,000 times, so it is more than enough that you can complete your task in 1,000 times. Yes, you can change this limit by writing something, but I will discuss that part. So how this function works, just come here. If you I have written this statement, the same function I have written, my fun and print Python, my fun, and I'm calling the my fun here. So when this function will execute, so first of all, it will go into the stack. We have already seen it a few minutes later. So what will be the stack format? Just look at here. My fun will be in a stack, and after that it will reach at this location and it will print the Python. So after that you will see that the output will be your Python. Okay, And when this statement will get finished, you are calling the my fun again. Okay, so when this function will be called, so this my function again calling to itself. So my fun will be execute one more time. So my fun will be execute and it will print the Python. So next time it will, you will see that Python is as output and this function is calling itself. So my fun. So one more time you will be on a stack, and after that you will get the output as Python, and again this function calling the itself, so it will be on the stack. So as you can see that our stack is getting uh, increasing by the putting the function into it. Okay, so this will be continue until your recursive limit is not reached, or in other language we can say that your stack is not full. Okay, so what I'm trying to say here, this is the very basic of the recursion. But remember this one: when you write any recursive function, and if you try to write any recursion type of the code, so make sure that you have a base condition on which you want to stop the execution. Otherwise, it is useless. Okay, so first of all, if you have a base condition mentioned in your function that at this time I want to stop the execution, I want to get back at that location from where I have been called. So this is one point that you need to remember. Okay, so this is the point. Now sometimes we say that we can perform the same thing that we can do the iterative way, that we can do by using the by the recursive way. So yes, this statement is fine, but all the operations that you perform through the recursion, and all the operation that you perform through the iterative way, it is not mandatory that you can convert all the things into vice versa. Okay, so for example, there is a problem that is called Tower of Hanai. So that can be solved by the recursive functions. Okay, so let's see a few examples that we can do with the recursion. We know that we can calculate the factorial of a given number. So how do we calculate the factorial of a given number? Very simple. We calculate the factorial of any number like this. For example, if I want to calculate n is equal to 5, so what we do actually, we perform this operation. I hope this statement is clear, that we perform this operation to calculate the factorial of this. So we can do this by the iterative way. We can start the loop from 1 and multiply by the numbers, and we'll get the answer and we can generate it. So I hope this logic is clear, that how to do this by using recursion, sorry, iterative way. So if you want to do this by the recursion, then you can do this. So first of all, remember this: when you start the execution, then we can flip this. uh, I can write like this: 5, then multiply 4, then multiply 3, then multiply 2, then multiply by 1. So as you can see, at this location I want to stop. So and one more thing, if the user provide the input as 0, so we know that the factorial of 0 is 1. So the base condition is, if the n reaches at 0, then we will return the value as 1. So this is our base condition. So by using this, let's try to write a factorial recursion method. So here I am writing that is my fact. Okay, and to calculate I will pass a number here. So here I will write for example 5. So I will pass into my fact, that is 5. Okay, and it will return the result. So I will store that result into a variable. Okay, now what will be the code inside it? So the base condition is, if n is equal to 0, so I will return from here, and I will return 1. Else what will I do? As you can see here that we are performing the operation like this 5 into 4 into 3 into 1. So this can be written as, I can write this whole statement is, this is the factorial 5. So here I can, this is the factorial 3. So I can write like this, my fact, that is 4. Okay. So this my fact 4 will be equal to 4 into 3 into 1. And when I will write this one, then I can write this statement as, because it will be generate as 4 multiply by 3 multiply by 2 multiply by 1. So as you can see, this is equal to this. Okay, so I I can see here that this number is multiplied by factorial 3. So I can write here 4 into multiply by my fact. I can call the same function, and here I can pass 3. Okay. Similarly, you can see here that 3 into 2 into 1. So it means I can write the statement as, this statement can be written as 3 into factorial of 2. Okay, and this statement can be written as, this statement can be written as 2 into factorial 1, and this statement can be written as 1 into factorial 0. Okay, I hope the statements are clear. And this statement is equal, this my fact, when it will be 0, so n is 0 here, so it will return 1. So when it will return 1, so it will produce the output 1 into 1. Okay, so now it will return from here. So look at here that what I'm doing here, if n is equal to 5, if n is equal to 5, so what I'm doing, I am passing here n minus 1. As you can see, this is n minus 1. If n is equal to 4, then I'm passing n minus 1, that is 4 minus 1. Okay, so and what I'm doing, this is n into my fact into n minus 1. So I can write here that return the product of n multiply by fact, that is, sorry, my fact. Okay, return from here, that is my fact. Copy, let me copy this, my fact, and here I will pass n minus 1. Okay, so when I will execute this code, then you will find that we will get the output as, so as you can see that we are getting 120. Okay, so actually this is the process of this execution. Okay, so this is the stack that is maintained by the program. So when your n will be 0, so it will return 1 from here. So it will be 1 into 1. Okay, so it will return 1 to this function. So it will multiply by 2, 2 into 1. It will return the result to this function. So this is 2 into 1, that is 2. 2 into 3, that is 6. It will return to this function, that is 6 into 4, that is 24. 24 will be returned to this function, and 24 into 5, that is 120. So you will get the result as 120. So this is the way that actually your recursion works. So this is the example. Let's do one more example. For example, if you have any number, for example 1 2 3 4, and I want that addition of all the digits of this number, so what will be the answer? So we can do this by the iterative, but the requirement is I want to do it by using the recursion. So how you do this operation? First of all, what you do, first of all, you extract, actually what you do, first of all, you extract this number. Okay, and you add to this extracted number, then add to this extracted number and this extracted number. So how to do this? By using the mod operation, you get the extracted character last digit. So first of all, you write x is equal and n mod 10. So you will get the last digit, and after that you modify the number by using the division by 10. Okay, so I will do I will write the same process by using the recursion. So here I will write sum of digits. Okay. So what will be the base condition? The base condition is until your number is not reached at the zero, means division has been finished, all the division numbers has been extracted, then your number will become zero. So this is the base condition. So if the number is zero, so I will return here from the here. Okay. And uh, what you want to return, so I will return zero, no problem. And else if your number is not zero, so first of all you will extract the mod. So here I will write, first of all, extract the mod from here and add it to the next extracted character, that next extracted digit, that will be the 10 times lesser than the actual number. So here I will write n divided by 10. Okay, so this is the simple logic, and here I will copy paste, and number is 1 2 3 4 5. Now let's see at what is the output. So as you can see that the sum of number is 15. If you pass any number, then you will get the result, that is 31. So you can sum up. So this is the way that your recursion works. So I hope the recursion is clear. If still, if you have doubt, then you can put your queries into the comment box. So I hope the recursion working is clear. Recursion means when a function call itself, it's called recursion in programming. So thank you for watching this video. Please like, comment, and share your views. Share the videos with your friends, and don't forget to subscribe my channel. Thank you. Bye bye.